Functions f and g are defined by f of x is equal to e to the minus x plus 2, where x is a real number, and g of x is equal to 2ln x, where x is greater than 0. Find f(g) of x, giving your answer in its simplest form. So this is saying to take the g of x function and substitute it into the f function. So take this and substitute it in here. So we can say f of g of x is equal to e to the minus 2ln x plus 2. Now to simplify that, so I need to deal with that minus 2. If I move that to be a power here, then I'll get e to the ln x minus 2. And that's a good thing to do because then the e and the ln cancel out, which allows me to just say I've got x to the power minus 2 plus 2, which if you wanted to, you could write that as 1 over x squared plus 2. So that's my answer to part A. Part B finds the exact value of x for which f of 2x plus 3 is equal to 6. So this is saying to take 2x plus 3 and substitute that into the f function. So we would get e to the minus 2x plus 3 plus 2 is equal to 6. I will then subtract 2 from both sides. I'm then going to take logarithms of both sides. I can then add 3 to both sides. And then divide both sides by minus 2. Which is a bit messy. I can tidy that up a little bit. ln 4, I can deal with that 4, because I can write 4 as 2 squared. So let's do that. Because that's useful, because then I can write it as 2 ln 2. And when I divide that by minus 2, I'm going to get minus ln 2 minus 3 over 2, which is probably a little bit simpler. Anyway, that's my answer for part B. Part C finds f minus 1. Find f inverse, stating its domain. Right, well, f inverse, so let me first write down the f function. I know f inverse flips the x and the y. So let's swap the x and the y around. Let's now take, let's take away 2 from both sides. Just trying to make y the subject here. Take logarithms of both sides. And times both sides by minus 1. So this is my inverse function. This is my f minus 1 function. I need to state its domain. I could do this by thinking about the range of this function here. Or I could actually, because it's a logarithm, I know what's on the inside here has to be greater than 0. I know I can't do a logarithm of 0 or logarithm of negative numbers. So I know that x minus 2 has to be greater than 0. So therefore I know that x has to be greater than 2. That's probably the quickest way of stating the domain here. Like I say, alternately, you could have thought of the graph of e to the minus x plus 2. E to the minus x looks like this, going through 1. So e to the minus x plus 2, and also this has an asymptote at y equals 0. So this is the e to the minus x. So e to the minus x plus 2 will just be exactly the same, but 2 higher. So we'll now have an asymptote here at y equals 2. And therefore we could say, looking at that, that the range of the original function is that y has to be greater than 2. And if the range of the original function is y is greater than 2, then the domain of the inverse function has to be that x is greater than 2. That's often the way. The only reason I'm doing that example as well here is because quite often when it says stating its domain, that's the way I do it. I flip the range. I find the range of the original function and then just use that. But in this case, it was obviously much quicker just to do the first method. Right, finally, part D. On the same set of axes, so let me draw a set of axes here. Right, on these set of axes, I need to draw the graph of y equals f of x, which I just drew a moment ago actually, so let me draw that back in. The graph of this, remember it had a y asymptote of, it was y equals 2, and it intersected here at 3, and it looked like this. So this is the graph of e to the minus x plus 2. That's my f of x function. Now I need to draw the graph of f inverse of x. Well, I know that's going to be a reflection in the line y equals x. The inverse is always a reflection in the line y equals x. So if I reflect the asymptote, first of all, that's going to be at x equals 2. And then it's going to look like this. Cutting through here at 3. And intersecting there on the line y equals x. That the wrong way around, it should be looping away, so it will intersect here at 3. It will intersect here. That's going to look more like this. And so that's the graph of f inverse of x, which, if you remember, was the minus ln x minus 2. Obviously, you can always put these into your graphical calculator and use that to help you as well here.